So, in previous video, we were talking about the oxidation state and the oxides of the compound. There we have decided how to convert them into oxides by their oxidation state as well as their physical properties like whether they are ionic or whether they are covalent, as well their acidic character we have discussed. Okay, so now here I am going to dictate you oxide of vanadium, oxide of chromium, oxide of manganese and oxide of Fe. These are the basic things. Here vanadium oxide has up to 5. So total vanadium oxide is VO, V2O3, VO2 and V2O5. Chromium oxides are CrO, Cr2O3, Cr2O2, Cr2O5, CrO3. These are the chromium oxide. Manganese oxides are MnO, Mn2O3, MnO2, Mn2O5, MnO3, Mn2O7. Okay. Now Fe oxides are FeO, Fe2O3. Only two oxides are available in the nature. So this is our talk about the oxides. Now oxides of vanadium, chromium, manganese should be discussed, because Fe is only two oxide, and this oxide we have studied very nicely in previous 11th standard. So there is no important there. Only important that this when FeO plus Fe2O3 combine together and by mixing of they are making Fe3O4. So Fe3O4 is mixed oxide of FeO and Fe2O3. The total Fe4, Fe3 and oxygen 4. So this is only to study about the iron oxide. But here lots of exciting and oxide interesting thing we are going to study about this all. Okay. So we can study about that first MnO. Okay. MnO can be converted into ions. So how many ions are there? So one most famous ion of this MnO is MnO4 minus. Another one is MnO3 minus. Okay, and another one is MnO4 minus 2. Okay, so these are the oxides. Out of these we are going to discuss about these two oxides. Oxide ion of MnO4 minus and MnO4 minus 2. Dear students, this is minus 8, this is minus 8. Minus 8, that means 8 minus 1 is plus 7 oxidation state, and here 8 minus 2 is plus 6 oxidation state. What you have to remember? You have to remember that when such different oxides are there and according to their oxidation state, we can nomenclature them. अगर higher oxidation state હોય તો પાછળ લગાડવાનું છે 8. પાછળ શું લખવાનું છે? પર 8. But remember, what is the highest oxidation state according to this is nothing but here plus 5. Here plus 6. So plus 6 should be considered as the highest oxidation state. Plus 7 પણ આવે, પણ plus 7 ખાલી એકમાં જ જોવા મળે છે. So that known as extra. So here it should be highest oxidation state 6, and that's why it should be add as a 8. અને અહીંયા highest oxidation કરતા પણ એક ઓક્સિજન વધારે છે. That's why it is used as a per 8. તો જ્યારે highest oxidation state કરતા એક વસ્તુ વધારે હોય તો તેને આપણે per 8 લગાડીએ છીએ, and that's why the name of this is permanganate, and name of this is manganate. Manganese પરથી manganate અને manganese પરથી manganate જ બનવાનું છે. but એક ઓક્સિજન વધારે છે here ઓક્સિડેશન સ્ટેટ અહીંયા +6 ના બદલે +7 the highest oxidation state કરતા પણ એક સ્ટેટ વધારે છે, that's why it is known as permanganate. So this will be the permanganate and this will be the manganate of the ions of this group. Okay, so I hope that you understand this. Here negative ion we have discussed, but in this case we can discuss some positive ion also. So might be MnO plus 2 is possible. How? MnO plus also possible and MnO plus 3 also possible. So here question arises કે શું આવા આયનો બની શકે? So maybe positive ion are exist in nature. artificially આપણે બનાવી શકીએ, પણ in nature આ લોકો સ્ટેબલ રહી શકે કે નહીં રહી શકે? that is the important question. For example અહીંયા -2 છે તો +4, -2 છે +3, -2 છે +5. So like that lots of positive ion of the Mn can be made. But dear students, the problem is that they are not naturally available as well. When they once they prepare, they are not remaining in ion form for longer time, and that's why so manganese ions are this, and these ions are we have discussed nicely. So hope that the manganese oxides and its ion formation and its nomenclature you understand. Now we are going to talk about the different thing here. Here chromium has different oxidation state, and now which will be the acidic and which will be the basic, that will be the discussion point. Okay, so dear students, in exam such question is asked, can explain CRO is acid, sorry, CRO is base, while Cr2O3 is neutral. Discuss. So question છે આપણા પાસે આવો question છે, ન્યુટ્રલ ના બદલે અહીંયા છે amphoteric. Discuss your answer. So this is the question. Explain CRO is base while Cr2O3 is amphoteric. Why this is happening? How can I say? So what you have to explain? In CRO, solution is like this. This is the question, and solution is like this. In CRO, the oxidation state of Cr is +2, and in Cr2O3, the oxidation state of Cr is +3. And now we know that when the smallest oxidation state is there, it is behaving as base, and when higher oxidation state is there, then it is behaving as acid. But 3 plus 3 is neither higher nor so small, and that's why Cr2O3, CrO2 like oxides will behave as amphoteric material. So hope that simply you can give the reason these oxides is basic and these oxides is amphoteric, or this oxide is acid and this oxide is neutral. How these answers come, you understand that. So about CRO we can make this. Okay, now we are going to study ions of CRO. Okay, so very famous ion of CRO are CrO4 -2 and Cr2O7 -2. These are the very famous ion of chromium. And dear student, here +7 oxidate, +6 oxidation state, and here is also +6 oxidation state. As here +6 oxidation state, that is the highest for chromium. That's why we have to use at suffix, and then we have to pronounce it. So this ion CrO4- ion, that is known as chromate. That is known as chromate because the highest oxidation state is 6 and highest oxidation state હોય તો 8 લગાડવાનો. That's why this ion is known as chromate ion. And here 2 times Crs are there. That's why this will be known as dichromate ion. Okay, as well we have another CrO3 minus 2 also there. And in CrO3 minus 2, this will have oxidation state 3 to the 6 માંથી ગયા હતા +4. So +4 oxidation state is there. That is the downward. And જ્યારે ઓછી oxide state હોય ત્યારે આપણે શું લગાડવાનું છે I. And that's why this will be known as chromite. Okay, so FeCrO3 આવું તમે સાંભળશો ભવિષ્યમાં કે FeCrO3. So nothing but this is the iron chromite compound. Iron chromite compound. So this is our topic about the nomenclature. So chromium ion has this kind of positive and negative compounds. So chromate, dichromate and chromites are the ions formed due to the Cr. Chromium na લીધે આ બધા ion produce થતા હોય છે. Whether these are producing positive ion or not, that we can also discuss, but here no discussion of the positive ion of these chromiums are taken, so we will not take any bother about this. But we can talk about the positive ion of vanadium and titanium. So I will add here now titanium, because I have no place here to write, and that's why I have first to discuss about the manganese and chromium. Now we are going to compare the oxides of titanium and vanadium. Titanium should have Ti2O3 and TiO2. These are the oxides of the titanium. Now first +2 +3 +4 +5. Out of this, which is all acidic and which is basic and which is amphoteric in characters, that you know, everyone knows. But here I should like to discuss about the another ion, and here the very famous ion of vanadium that I am boxing. Why it is boxing? Because now we are going to study positive ion, and this positive ion is VO2 +1. So VO2 +1, this is the positive ion made by metal oxide, and this is more interesting because until we have studied that hydrogen can produce the positive ion. Here vanosodium, okay, like that nitrosonium was the ion NO+. NO+ is known as nitrosonium. Okay, so this is the vanosonium ion. What is the name of this? Vanadosonium. Vanosonium or vanadosonium ion is this. So hope that you understand that vanadium is producing positive ion even. Okay, as well titanium is also producing positive ion, and it is famous TiO+. TiO+ is the famous titanium's positive ion, and actually +2 છે એટલે મેં જોયું. So TiO+2 is the famous titanium positive ion, and both are stable. These both ions are stable. Here the oxidation state of the oxygen is this, and this will be +3. So 3 - 2, and titanosonium. Titanosonium is the name of this ion. So there are two ions you can consider. What about the vanadosonium and titanosodium? Sonium is the suffix for this positive ion. So I hope that you understand the positive ion of this. Now we are going to discuss about the negative ion of this thing, and negative ion are also existing here, and the negative ion is VO4, that is the -8, and this will the maximum is 5, so above you have to write -3. So VO4 -3 is the ion which is produced by the vanadium. And what should be the name of this? The highest oxidation state is +5, and that's why here we have to add and now make your name with this thing. So I hope that you understand how the vanadium is producing the negative ion. Okay, and what should be the name? Vanadate. What is the name of this? vanadate ion, chromate ion, manganate ion. Like this, vanadate ion is the name of this compound, this ion. So hope that you understand the things. Now, this is the most important question, most Olympic question I am going to discuss with you, and that will be the end of this video, and the oxides entirely I have completed with this. So what is the most important question? Vanadium pentoxide is amphoteric in nature, but it is more acidic. Explain your answer. Vanadium pentoxide is amphoteric in nature, but it is more acidic. That will be the question, and how you will discuss this, that is the important question. So vanadium pentoxide V2O5 can convert itself into VO4 minus 3 ion and VO2 plus ion. It can convert it into VO4 minus 3 ion and VO plus ion also. And this will be the beauty of this thing. Any beauty? Both are having plus 5 oxidation state. But dear students, this is behaving as an acid. This is amphoteric. But this is behaving as an acid and this is behaving as a base. Acid तरीके काम कर रहे हैं, base तरीके काम कर, and that's why vanadium pentoxide is believed as an amphoteric material. I hope that you understand this point. What is the point? The point is vanadium pentoxide can be thermally decomposed into the VO4 minus 3 ion and VO4 5 plus ion. VO4 minus 3 is actually acid and VO2 is actually base. Okay, and that's why when both combine to give this is as a amphoteric material. But when we decompose there, then it will become in more amount and it will become in less amount, and that's why vanadium pentoxide is more acidic in nature. Now these things all are not given in your book, okay, but though I am explaining this. Okay, so this is our talking point, and I hope that you understand this very nicely. Okay, so this is our topic. Now vanadium pentoxide ની અંદર બેઝ હશે, આ લેસર બેઝ હશે, આ તેનાથી વધારે, અને આ એમ્ફોટેરિક બની જાય છે. So this is the discussion of the vanadium pentoxide. So hope that entire oxides of these D block elements their nature થી માંડીને એ લોકના કેવી રીતે કમ્પાઉન્ડ બને છે, એ લોકના આયન્સ કયા કયા છે, આ બધું જ આપણે આ બે વિડિયોની અંદર ડિસ્કસ કરી લીધું, and that will be give you more and more idea about the D block elements and its reaction. Hope that you will do this thing with this. So here I have explained nearby 5 questions. These 5 questions you have to write in assignment. Otherwise I will provide you the question in differently. All the best, dear students.